So let's look at the next part of this, the perimeter of a sector. So once we talk about perimeter, what do we mean here? Perimeter is all about adding the distance around a given figure. So let's say we have a circle here, drawn here, and having a center O. Let's say this is the center. So I have a radius drawn from here. Let's call this center O, and this point A. And I have another line drawn from the center to this part of the circumference, and I'll call here B. So, as we know, line O to A is the radius of the circle. Line O to B is also the radius of the circle. They are equal. And the angle between them is theta. And as we know from the previous video, that the length of the distance from A to B is called an arc. So AB is the length of the arc. So, but in this case, we are trying to calculate the perimeter of the sector. So the sector here is actually AOB. That is, let me draw it here. Sorry. The sector here is this figure. So everything here, this is a sketch. So let me call here A, and here O, and here B. So by talking about perimeter here, perimeter means I will add everything around the shape. I will need to go around the shape. Let's begin from A, add everything here, add everything here, and then add everything here. Yes. So if you go around the shape, you've just gotten the perimeter of a sector. So what comprises of this whole thing here? So it's I added here, so this is my R. So perimeter of a sector is given as P equals to, for perimeter, OA or AO is R radius plus, I went to OB. OB is still R plus A to B is an arc. Yes, arc AB. So we'll add arc AB. So let's call it the length of the arc. That is, let's call it L. Yes, so AB is the length of the arc. So putting this together, we now have P equals to R plus R is 2R, then plus L. So but L, we've done L in the previous video. L is the length of the arc. So if I'm to put all now together, we have P equal to 2R plus the length of the arc is theta over 360, theta over 360 times 2 pi r. Yes, so this gives us the length of the arc. So altogether, the formula for finding the length of an arc is this formula here, P equals to 2r plus theta minus theta over 360 times 2 pi r. So let's look at a few questions that we can solve to help us understand this properly. So the first one here is calculate the perimeter of a sector which obtains an angle of 90. So just write out the parameters that we need from this question here. So um, we then have this. So our P calculate the perimeter. So we don't know. Let's write P as using a question mark. We don't know. which obtains an angle of 90 degrees. So 90 degrees. An angle theta is equals to 90 degrees at the center with a radius of 21. So r radius equals to 21 centimeters. So without wasting time, what is the formula? Formula is P equal to 2r plus the length of the arc plus L. But L, you know what L means? L means theta over 360 times 2 pi r. So what's next? We now have P is equals to 2. What is our R? R is 21. 21 plus theta is 90 here. 90 over 360 times, we have 2 here, times, I think from the question, we are not told to take pi as anything. So since I'm not asked to take pi as anything, I will take pi as 22 over 7. And I'll have 22 over 7 times R is 21. Our R is 21, so I will have 21. So P becomes equal to 2 times 21, you should know is 42, plus, for this one, let's multiply the numerator as usual. Numerator, then you multiply the denominator and then divide. So 90 times 2 times 22 times 21 should be 83,160. 83,160 all over 360 times 1 times 7 times 1 should be 2520. And then P becomes equals to 42 plus, divide this number, this figure you have divided by 2520, we are getting 33. Yes, 33. So finally, to get the perimeter, 42 plus 33 should give us 75. 75 centimeters. So this is the answer to our question 1. That's the answer to question 1. 75 centimeters. So question 2 says the angle subtended by a sector of a circle is 70 degrees if the perimeter of the sector. So let's put the same thing down. Just put the same thing down. List out your given parameters and you're good to go. The angle subtended by the sector of a circle is 70 degrees. So here theta is equal to 70 degrees if the perimeter of the sector P, if P is 105 centimeters. Now calculate the radius. The radius we don't know. So check this question. There is a key sentence there. Perimeter of a sector. That is a key word there. So you've heard it, meaning that you apply the same formula for perimeter of a sector. So we'll start by stating the formula. So what is the formula saying? That P is equal to 2R plus the length of an arc. And of course, you know what the length of an arc means. The length of an arc is simply theta over 360 times 2 pi r. So let's see. So check, plug in what you're given. Our P here, this is the formula I'm using here. My P here is given as 105. So we are given P as 105. So we write 105 equal to 2. We don't know R. This R here, it has no value here. So we don't know R. So I'll leave it vacant. So I don't know R plus theta here is 70 degrees. This value here, theta is 70 degrees. So I have 70 over 360 times 2. I'm not asked to take pi as anything. So let's take pi as 22 over 7 times 22 over 7 times. The radius still, I don't know, r over 1 over 1 here. So let's continue. Let's keep solving. 105 is equals to 2r plus. Now multiply the numerator value. 70 times 2 times 22. 70 times 2 times 22 is 3080. And 3080 times that r you're seeing there should give us 3080r. All over 360 times 1 times 7 times 1 is 2520. Okay, so what can we do here? Some might be tempted to say cross multiply, but that's wrong. I can't cross multiply yet here. Why? Because there is still 2r here. There is 2r here. If this 2r was not here, if 2r was not here, I will just have to cross and multiply. That is, I'll call here over 1 then. I'll call here over 1 and then I'll do this. Then 3080r times 1 should give us 3080r. 2520 times 105 and so on. But that's wrong. That's wrong. So I can't go like that yet. So I need to work on that bracket there. I will have 105 equal to 2r plus. This is why I recommend you buy a casio calculator. Yes, or any calculator you have at all that is scientific should work. So what you will do here, if you can divide the lowest term by your hand, fine. But I'm not. I'll use calculator work all through to save our time. So 3080 divided by 2520. So once you punch it on the calculator, it gives us the answer in lowest term as 11 over 9. So I'll have 11 over 9. But we have an R beside it there. Yes, so what next? What will I do here? Let's find the LCM here. Let me call here over 1 and here over 1 as well. So looking at the denominators from left to right, from the left hand side to the right hand side, the denominators here are 1, 1, and 9. So what is the LCM of 1, 1, and 9? The LCM of 1, 1, and 1, 1, and 9 is just 9. Yes, the LCM of 1 and 9 is just still 9. So I will now have to multiply everything by the LCM. I will say multiply, multiply through by LCM. So the LCM is 9. So multiplying all through by 9 goes this way. I'll put 9 here. Sorry. I'll write 9 here. Now 9 multiplies 105 divided by 1 is still 105 equal to, I have my 9 again. 9 multiplies 2r divided by 1 still gives us 2r plus multiply again by 9. So 9 multiplies 11r over 9. So what happens here now? Multiply 9 by 105. 9 times 105. We're having 945. 945. We're having 945 equal to 9 times 2r. We get 18r plus 9 in this denominator. We cancel this man up here. So I will have what left? 11r. So with this, it becomes easier. So at this point, we now take like terms. Let's stop up here. So I will now have 945 is equal to 18r plus 11r should be 29r. 29r. So to get my r here, I'll have to divide both sides by 29. To get my r, I'll divide both sides by 29. So that 29 will cancel out here, leaving us with r. So I'll have that r is now equal to 945 divided by 29. 945 divided by 29 is giving us 32.586 and so on in centimeters. So, but I'm not to do any approximation here, but let's just approximate since it's a very long decimal. And I'm working with centimeters. I'll prefer I approximate to one decimal place or two decimal places. So if I'm to go for one decimal place, my R becomes approximately the first. I want to go for one decimal place. So the first decimal place here is 5. What is next to 5 is 8 and is up to 5. So I will take 1 from 8 and add to 5. It becomes 6. So I now have 32.6 centimeters. And that's the answer to this question. So the third question, it says a rope of length 18 centimeter is used to form a sector of circle of radius 3.5 on a playing field. What is the size of the angle of the sector? So we need to think critically for this question. It says a rope of length. Just imagine having a rope with you. Imagine yourself having a rope with you. Let's say this is a rope here. For example, this is a rope here. That this rope is 18 meter long. 18 meter long, and it's used to form. Is it 18 meter or 18 centimeters? Let me check. Okay, 18 centimeters. So 18. Let's say it's 18 centimeters long. Yes. So let's say the rope is 18 centimeter long. So imagine yourself having a rope 18 centimeter long, and you use the rope to form a sector. Of course, you know how a sector should look like. So let's say the sector looks like this. Let's say it looks like this. Let's assume it's like this. Let's say you have a sector this way. So what is saying that this 18 cm rope, you folded it until it formed this shape. So and we are told that it formed a circle of sector of radius, that the radius became 3.5. So meaning that this is 3.5 centimeters, and here also 3.5 centimeters. That's what it's talking about here. So that having formed the rope, or having folded the rope to form this sector, that we have to find the angle here, the angle here, theta. So, and that's all. So what can we say about this whole information here? If you observe, the rope is 18 centimeter long. No length was lost. That same 18 centimeter was folded to form a sector, meaning that the length of the sector, that is the perimeter of the sector, should also be 18 centimeters. So I can write that my P is equals to 18 centimeters. That is perimeter of the sector. So we are asked to find, okay, we are given the radius of the sector to be 3.5 centimeters. And here we are asked to find the angle of the sector, which we don't know. We don't know. So since I don't know the angle, I think my diagram might be affected because I don't know how it will look like. So, but if it's an accurate angle, I think I have a correct diagram. So, but notwithstanding, this is a sketch. I'm only sketching. So, this is plainly a problem on perimeter of sector. So let's see how we can apply the formula here. So we now have here from the formula of perimeter of sector that P is equal to 2R plus theta over 360 times 2 pi R. Yes. So the perimeter is given to us as 18 because the sector was formed from the same length of the wire. So it's 215. Sorry, it's 18, not 15. 18 equal to the sector now have a radius of 3.5. So my R is 3.5 plus theta here. We don't know. We're asked to find the angle. So I don't know what theta is. Theta is here over 360 times I think we are asked to take pi as okay, nothing. So I will say take pi as 22 over 7. So theta over 360 times 2, my pi should be 22 over 7 times my r. We're given the radius as 3.5. I have 3.5. So let's call here over 1 and this over 1. So we're having 18 equals to 2 times 3.5 should be 7 plus. So as usual, multiplying the numerator, we have 2 times 22 times 3.5. That's 154. So 154 times theta should still give us 154 theta all over 360 times 1 times 7 times 1 is just 2520. So what's next here? We can take like times here already because okay, or let's divide first. Let me solve this side. I will have let me solve this side. So I will now have that 18 is equal to 7 plus, let's do 154 divided by 2520. 154 divided by 2520 is 11 over 180 is 11 over 180. And of course, there is theta up in the numerator. So what will I do here now? Let's take like 10. Let's move 7 to the left to become 18. If 7 goes to left, it becomes negative. Negative 7 equal to, I will have 11 theta over 180. So 18 minus 7 is 11 equal to, I have 11 theta all over 180. So I can call here over 1 and then cross and multiply. 11 theta times 1 is still 11 theta. 180 times 11 is 1980. That's 1980. So to get my theta, I'll divide both sides by 11. Dividing both sides by 11. 11 cancels out. Theta is now equals to 1980 divided by 11 gives us 180 degrees. And that's the answer to this question. 180 degrees. I think, like I told you from our sketch, um, although we sketch, um, but the angle does not correspond to what I sketch. But you're correct in your in your calculation, like you are correct. Just that, like I said, angle 180 is angle on a straight line. Yes, angle 180 is angle on a straight line. So this angle here, I drew this before, because I never knew the angle that would be here from the onset. So I just gave a sketch. So, but in the in reality, the diagram is meant to, since I now know my angle, it then means that the diagram is meant to look like this. It's meant to look somehow like this. Yes, showing that this is our center here. Because angle one, so angle on a straight line is angle 180. This angle 180 here. So this is where I should have had my 3.5 centimeters. Here, 3.5, that is the radius centimeters. So this is just how it should look like. And theta is 180. So that's it. So let's look at question 4. The perimeter of a sector is 27.2. This is just similar to question 3. Just that we are given the diameter. So it's just the same thing. So to solve question 4, so we are given the perimeter as 27.2 centimeters and the diameter to be 14 centimeters. So we have to find the angle, and this time around we're given pi as 22 over 7. So how do we solve this problem here? It's just the same thing, just the same process. It's the same thing, exactly the same thing as we did in question 3. So let's now solve. So this is purely a question that relates to perimeter of a sector. So I have P equal to 2R plus um, theta over 360 times 2 pi R. So plugging everything here, our P is 27.2, right? 27.2 equal to 2. What's our radius? And we're not given radius here, but to get radius, I've told you before in the previous video, to get radius from diameter, you always divide by 2. If you're given your diameter and you want to get the radius, just divide by 2. If diameter is 40, divide by 2, 20 is your radius. If diameter is 50, divide by 2, 25 is your radius. If diameter is 14, as we have here, divide by 2, 7 is your radius. So I have here 7 plus the angle we don't know, so theta I don't know, over 360 times 2 times pi 22 over 7 times our r as we got before is 7 radius. So we have 27.2 equal to 14 plus multiply here 2 times 22 times 7 is 308. 308 times theta should be 308 theta. All over 360 times 7 over 1 is here. 360 times 1 times 7 times 1 is just 2520. 2520. So 27.2 is now equals to 14 plus 308. Let's divide 308 by 2520. We'll get 11 over 90. So I'm having 11 over 90. But don't forget that we have theta up in the numerator. So let's take like terms here. 14 should come to the left. I will have 27.2 equals to, sorry, 14 is positive on the right. When it comes to the left, it becomes negative. 14 equal to 11 theta over 90. So what is 27.2 divided by, sorry, minus 14 is 13.2. We have 13.2 equal to 11 theta over 90. So what do we do here? We cross and multiply 13.2, 11 theta over 90. So let's call here over 1. Cross multiply. 11 theta times 1 gives us 11 theta. 90, 90 times 13.2. 90 times 13.2 should give us 1188. 1188. To get my theta, I'll divide both sides by 11. Dividing both sides by 11. This will cancel this. So theta is now equal to 1188 divided by 11 should give us 108. 108 degrees. So that's our answer. I think that's all for this.